Welcome back with another video on TryHackMe.com. This is Zaheen Nazir and we are doing Hypervisor internals. This is a new room on TryHackMe.com, so we're gonna do it today. So let me join this room now. It have from task 1 to task 7, so it is just created today, as you can see. So let's get into it. Hypervisor internal. So it is a blue team room here. An introduction to the use of hypervisors and their internal components. Okay, task 1, introduction. Virtualization is a concept of creating multiple virtual environments from shared physical hardware. This is achieved by abstracting computing resources and allocating portion of these to the environment. Virtualization allows a multiple operating system to run on a physical device. Even this particular operating system, the Kali Linux, I'm running it using the virtualization. Okay, run on a physical device where the operating system do not interact or conflict with each other. These multiple environments are known as virtual machines, VMs. If you would like to learn more about the concept of virtualization, visit the virtualization and containers room here. Let's see if we have covered this one or not. We haven't covered it, and it's a very old one, so maybe in the later video I will cover this one as well. Host that provides virtualization as known as hypervisors. Okay, so hypervisors are an old concept in the computing. In the 1960s, the IBM released the first hypervisor that provides full virtualization, and CP40. Since then, the hypervisor landscape and virtualization technology have become sophisticated, and even from the backbone of the services such as cloud computing. We will discuss this in greater detail in the further tasks. These technologies provide many benefits in the modern IT environment, including cost saving, high availability, easier management, and scalability. So let's cover all of this by consolidating what would otherwise be done on multiple machines. Money is saved by reducing the physical footprint, rack space, as well as saving on power and cooling costs by consolidating into one server. That is very true. High availability. Hypervisors can be configured to offload their workload to another hypervisor in case of failover. Additionally, hypervisors typically run on powerful server hardware that often comes with redundancy, such as multiple power supplies and error checking RAM. Okay, so error checking RAM is a enterprise feature, by the way, which comes on enterprise servers only. Not only, some of the enterprise processes and some of the AMD consumer-based processes also have this error checking RAM as well. Easier management. Workloads running on a hypervisor are managed from an admin console. For example, you can directly access the virtual machine via SSH and display it through the admin console. This makes managing considerably easier than, say, 50 separate servers. Scalability. Hypervisors typically run on powerful computing devices because the resources available to a virtual machine can be controlled on a granular level. Virtual machines can be scaled up and down depending on their usage. Moreover, hypervisors make importing and exporting virtual machines easy, such as packaging up a virtual machine as an OVA, open virtual appliance. So this is the format that can be used, that is used by VirtualBox, and even this particular packaging can be used and exported through VMware and many other hypervisors. Okay, hypervisor solutions. Learning objectives: understanding how hypervisors work, their types and why they are used. Discover the hypervisor landscape, the application of hypervisor in a cybersecurity context. This is very important. Become familiar with internal components of a hypervisor, as well as how the guest additions that are used to add features to hypervisors can pose a security risk. Okay, with that covered, let's dive into these concepts further. So click me to complete the task. Sure, we do that. Task 2. Types of hypervisor. Hypervisors are divided into two categories, which define their position abstraction in relation to the hardware of the physical device. This task will explain these two categories and how they differ from each other. Type 1, bare metal. These types of hypervisor have direct access to a system's physical hardware, don't have to go through another operating system layer such as Windows or Linux, and are used to run many virtual machines on devices such as servers. Some benefits of Type 1 hypervisor includes performance, scalability, and sophistication. By having direct access to the hardware, bare metal hypervisor have full control over the available resources and do not have to contend with the overhead of an operating system. Scalability Type 1 hypervisor often run on powerful servers designed to run a large number of virtual machines. This makes it easy to scale various environments during high workloads. Additionally, Type 1 hypervisor can be clustered, meaning workloads can be distributed among each other. Sophistication. This hypervisor offering or dedicated to performance and reliability and often interact with multiple services such as entire vSphere suite and technologies such as large data lakes. Moreover, it is possible to include automation with some Type 1 hypervisor. So, for example, we have hypervisor like Hyper-V by Microsoft and VMware ESXi are great example of Type 1 hypervisor. And if you work enough in the for long enough in the IT field or in the computer science, you may know both of these. You may encounter both of these hypervisors. Additionally, Type 1 hypervisor from the backbone of cloud computing. A diagram depicting the structure of a Type 1 bare metal hypervisor has been provided below. Okay, so this is our hardware and this is the hypervisor, Hyper-V or VMware, and this is our guest operating systems that are running. Two VMs are running and then the application are running on top of the guest OS. So as you can see, there is no operating system between the hypervisor and the hardware here. All right, so let's move on to Type 2, hosted. This hypervisor, also known as hosted hypervisor, differ from bare metal Type 1 hypervisor because they run on top of an existing operating system such as Windows or Linux. Hosted hypervisors are usually found in small environments such as developers or end user, where only a small handful of virtual machines are required, such as running Windows on Linux, like I'm doing right now. Examples of hosted hypervisor included VirtualBox and VMware workstation player. You may recognize or use these to run your hacking machine. The benefits of hosting hypervisor include ease of use, free offering, and widely compatible. These hypervisors are installed on your device the same way you would any other piece of software, because they run on top of existing operating system. You are free to use the device for purpose other than running virtual machines, are typically friendlier to use the Type 1 than the Type 1 hypervisor. Free offering. Providers such as VirtualBox and recently VMware Workstation are free for personal use. This is a great way to get started with hypervisors. On the contrary, the bare metal hypervisors often involve complex and expensive licensing scheme and also compatible hardware should be there in order to run the bare metal hypervisor. Okay, widely compatible. Most hosted hypervisor offering are cross-platform compatible, meaning they can run on Windows, Linux, and Mac. A diagram depicting the structure of a Type 2 hosted hypervisor has been provided below. As you can see, there is host OS here between the hardware and the hypervisor itself. So host OS itself can have applications, but the hypervisor will have the guest OS and the application will run on top of this VM. All right. Okay, answer the question below. What type of hypervisors have direct access to the bare metal? Type 1. All right, awesome. What type of hypervisor do not have access to the bare metal but run inside and through another operating system? Type 2. Okay, awesome. Let's move on to the task 3. This task will introduce you to the market leaders in the hypervisor technology. Hypervisor derive largely from a similar code base where companies have developed their versioning and products into what they provide today. They often share common features and functionalities such as snapshotting and guest additions. As you progress throughout the module, you will become more familiar with the hypervisor listed below. Hyper-V, Microsoft's take on virtualization, is Hyper-V, which can be found on both a Type 1 and Type 2 hypervisor. In its Type 1 form, the Hyper-V is a dedicated operating system that provides cloud services such as Azure Computing and organizations on-premises workloads. A Type 2 hypervisor, Hyper-V, can be found on a desktop for features such as Windows subsystem for Linux 2 or WSL2. So personally, I'm not using hypervisor. I used to use that hypervisor, but the performance of the Hyper-V was not that great, and there were a lot of limitations. So I moved on to the VMware. So as you can see, I'm running this particular machine on VMware here. All right. VirtualBox, Oracle's VirtualBox, is a popular choice among hypervisor due to its open source, free, and cross-platform nature. This Type 2 hypervisor is usually found on personal devices such as desktop, where only a few virtual machines are expected to run simultaneously. All right. This is also a very good tool if you want to use a free open source tool. So this is the way to go. But for me, I have purchased a license for VMware hypervisor for my use. So this is what I am using right now. Not the Type 1, but the Type 2. VMware ESXi or ESXi is a member of VMware's vSphere suite. This Type 1 hypervisor is a popular choice for large-scale virtualization. Yes, many organizations are using this hypervisor. I have seen organizations moving from Hyper-V Type 1 hypervisor to VMware vSphere suite Type 1 hypervisor because of the scaling and all other things that comes along with the VMware. Especially because of the features such as clustering, automation, and high availability. The XSZ installations on multiple machines can be installed and connected to one another, allowing workloads to be distributed. The VMware includes a rich API allowing the automation of various tasks. They have ARIA automation available in the VMware sphere, which can be integrated with all DevOps technologies. Okay, for example, automatic snapshotting, VM deployment and management, high availability in the event of an error, failover tasks such as virtual machine restart and offloading are possible within the SZ. So this is the portal itself that is available as a Type 1 bare metal hypervisor, and the VMware Workstation is what I'm using. VMware Workstation is another hypervisor offering from VMware, previously requiring the purchase of a license. Broadcom VMware owner made it free for personal use. Workstation is considered a Type 2 hosted hypervisor and is more feature-rich than the alternative such as VirtualBox because of the features such as being able to organize VMs in the folders, finer controls over the network adapters, 3D graphic. This is a big thing here. Better performance, of course, if you're using VM Workstation Pro, than the performance of the VMs that are running on top of your personal computer is better than all other offering. All right. Additionally, VMware Workstation integrates well with its other products such as vSphere and SC. All right. So as you can see, they have a lot of VMs running here. So they have THM, they have Kali 2013, New, Forensic, Flare VM, Malware Lab, WinAx, RAM Knox, AD Lab Workstation 1, 2, and DC, Dev, Debian, Mail Server Test, Projects, Phonex, Win10 Dev, FM, VNX. They have a lot of it here. I think some content creator took this screenshot from his personal computer. QMO, also known as Quick Emulator, is another open source hypervisor. This hypervisor is known for its ability to emulate full systems. For example, QMO can emulate ARM on an x86_x64 host, making it an ideal platform emulating different hardware and environments. Additionally, QMO can be combined with KVM to have near native performance by executing instructions directly on the host CPU. While QMO has features of other hypervisors such as snapshotting, it can be arguably considered less user-friendly since it is used on CLI. However, with that said, front-end interfaces have been created that can be used. These two technologies, QMO and KVM, are often used in cloud environments due to their performance and compatibility. Awesome. So this is also an open source one, free to use. I haven't tried it yet, but maybe I will try it someday. What is the name of hypervisor that can be found as both a type 1 and type 2 hypervisor? What is the name of the hypervisor that can be found as both on type 1 and type 2 hypervisor? I don't know. VMware? It's a VMware or Hyper-V? Hyper-V or... oh, wait. They are looking for some specific terminology. Yeah, it's Hyper-V. VMware is also available, man. What is the name of open source hypervisor developed by Oracle? It's VirtualBox. Awesome. Let's move on to the task 4. Hypervisor in cybersecurity. Okay. Hypervisors have a dominant space in cybersecurity and can be used in various ways. This task will introduce you to relevancy of the hypervisor within the field security research. Virtual machines are popular among the cybersecurity community for numerous reasons, such as development, analysis, research, testing, penetration, pen testing, and red teaming. Development. Enthusiasts use virtual machines to develop their tooling or signatures in a practical, safe environment. I do the same. You must do the same as well. Analysis. Security analysts use the benefits of virtual machines to replicate various real-world scenarios by maintaining diverse software and operating system environments with minimal hardware. So, for example, if I need to do an analysis on one of my virtual machines, I will just boot it up, do my thing, and shut it down, and move on to the research testing or maybe pen testing on some other virtual machine. So, the virtual machine, the hypervisor in the cybersecurity is a must. Okay, research. Virtual machines also provide security thanks to their sandboxing mechanism. You can run tooling to investigate malicious code without risk of exposing your physical device. Researchers can take snapshot of a machine in a various state that can be reverted back to during experimentation with malicious code. This is true. Testing. This concept is conjoined with development. Virtual machines are a fantastic way to simulate scenarios and setups. For example, building an Active Directory network to aid in both blue and red teaming techniques for practice. Pen testing. Red teaming. Organizations such as Kali and Parrot distribute popular community tooling through their own managed operating system, Kali Linux and Parrot Security, etc., which are often based on a variant of Debian or Ubuntu. Running these environments in a virtual machine is recommended for security and ease of use. Snapshotting, of course. Adversaries and APT groups are increasingly focusing their efforts on hypervisor because they form the backbone of modern computing today. For example, why ransomware one hosts when you can ransomware a hypervisor and take down N+1 system. These types of attacks are emerging in the recent trends, such as Alpha V attack on over 50 organizations. Okay, for Scout 2024. With that said, Hypervisor can be considered a high priority target for sophisticated threat actors. So, ransomware basically encrypt the system unless you pay the ransom. And if you do something with your hypervisor, that means the N plus system will be down. So this is the diagram. We have remote user accessing something from the web. There is attacker. Attacker will do something with the sonic wall SRA, and he will be able to compromise the system which are running on the hypervisor with the sonic wall SRA, I think. Coupled with that, very few endpoint detection services run on hypervisor due to their nature. This means that there is a lack of oversight in these hypervisor systems, making them potential targets for an adversary. Organizations such as VMware post their security adversaries advisories and best practices. For example, VMware had its advisories portal. Let's check this out, what they have here. So it's coming from Broadcom, and I need to sign in order to access any of this, right? Yeah, so I'm gonna just skip this and move on. All right, hypervisor vulnerabilities. Hypervisors, like any system, are not without vulnerabilities due to the sensitivity and popularity of hypervisor platform, especially type 1 hypervisor. Discovered vulnerabilities can pay a handsome reward in various bug bounty programs and the underground market. For example, at the time of writing, Microsoft offers up to 250,000 for Hyper-V vulnerability submitted to its bug bounty program. Okay, this is a very handsome amount, man. Fortunately, vulnerabilities such as RCE or virtual machine escapes due to the hypervisor engine itself are rare to come across, but when they happen, it's a big deal. Vulnerabilities in these platforms usually present themselves within the management console. Additionally, these management consoles also share the risk of user misconfiguration, such as weak or no credentials, no lockout mechanism, and other insecure practices. Okay. As of the time of writing, what is the maximum amount that Microsoft offers for disclosed Hyper-V vulnerabilities? So it is $250,000. Okay, wait. This is not the right. What is the max? Max is this one, man. So why they did not accept it? Hint: be sure to include the $sign and comma. Okay, awesome. What category of use do cybersecurity analysts use hypervisor to analyze malicious code? Malicious code. We do research, right? Yeah. What is the name of one of the APT groups that has been identified as targeting ESXi Hypervisors? So what is their name? Alpha V. Yeah, and it was also mentioned in text here, right? So this is Alpha V. What? Maybe the spelling or wrong. Tech. APT group. Yeah, this is Alpha V. Yeah, spellings were wrong. Awesome. Let's move on to task 5. So here we are hypervisors, internals, virtual machines, VMs. Much like any regular computing device, have CPU, RAM, storage and network components. Hypervisors create virtual hardware components and present these to the virtual machines. By virtualizing these, each virtual machine thinks it has dedicated components. However, in fact, the virtual machines share the same physical components amongst one another. This task will introduce you to how these hardware components are virtualized, CPU and memory virtualization. Hypervisor use virtual CPUs to virtualize the CPU, which are mapped to the core available on the physical CPU. In modern hypervisor, a vCPU is not permanently assigned to a core on the physical CPU. Instead, the hypervisor will take the instructions coming from VM and spread these across the physical cores as needed. For example, if you have a CPU with 4 cores, a virtual machine with one vCPU, the hypervisor will provide execution time amongst these physical core 4 cores. For the use of vCPUs allows for better performance whilst tricking the virtual machine into thinking it has a physical CPU. Additionally, this method allows you to assign more vCPUs to the virtual machine without requiring more physical CPU cores. Generally, the best practice is to limit the number of vCPUs in use to the physical core available to prevent over subscribing. Okay, so we have number of processors is 1 and number of cores per processor is 2. So the best practice is to limit the number of vCPUs that we will use to the physical cores available to prevent over subscribing. Okay, all right. Storage virtualization, known as a virtual storage device. A hypervisor uses virtual disk to create the illusion of a virtual machine having its own physical storage drive, when in fact it is shared host physical storage device such as a hard drive. Each hypervisor uses its own format to denote a virtual storage device. For example, VMware uses VMDK, where the VirtualBox uses VDI, right, for the devices. So if you have the NVMe available, then it is recommended to use that because it's very fast storage device, storage SSD, and if it is available, it is recommended to use it because it will improve the overall performance of your virtual machine. Network virtualization, much like CPU, RAM, and storage, hypervisor abstract the physical networking devices of the host machine to the guest virtual machines. The abstraction is achieved by using virtual network interfaces, VNICs. The VNICs work just like a network adapter and handle data obtains an IP address and are assigned a MAC address. The guest virtual machine can have multiple VNICs attached, for example, operating on a different subnet simultaneously, while one physical network adapter on the host is used. Additionally, VNICs allows for multiple virtual machines to communicate with one another on the same network. This is very true. There are multiple types of networking with virtual machines. These have been provided in the table below. Type and description. Bridged. This type allows for a VM to appear as if it is another device on the host network. For example, the guest VM will obtain an IP address on the same network as the host. NAT. This will with this type, all guest network activity appears as if it is initiated from the host. Host only will only allow the guest to be accessible from the host itself. The specific type allows you to manually assign what VNIC is used by the guest, and hypervisor allow you to create VNICs where you can specify what subnet and address range is used. For example, you can create VNIC that assigns IP address 10.10.10.0.24 and then configure each guest to use that VNIC so that they will all be placed on 10.10.0.24 and can communicate with each other. So this is networking within the VMware. You can use it to create your own virtual lab, okay, where different OS or VM can communicate with each other, especially in the Active Directory domain kind of things. Okay. Para virtualization, unlike full virtualization, guest virtual machine using para virtualization are aware that they are operating on virtualized hardware. For example, the guest knows that CPU, RAM, storage, and network are virtualized. This allows the guest virtual machine to make direct calls to the hypervisor. Generally, para virtualization allows for better performance as there is less overhead due to the fact that the hardware is not fully emulated, as is the case with the full virtualization. However, the guest operating system needs to support para virtualization for this to work, so it is not entirely possible in every case. Hypervisors such as KVM uses a combination of full virtualization and para virtualization to achieve its performance. For example, KVM uses para virtualization for I/O, disk read, write, and network activity for its performance increase, whilst using full virtualization for components such as CPU and RAM for compatibility. Awesome. Nested virtualization. Nested virtualization allows for virtual machine within virtual machines. For example, running VirtualBox within a guest. This is achieved by using hardware-supported virtualization such as Intel VTX and AMD V. These technologies are features within the CPU that manage virtual machine operations directly rather than using the hypervisor as the middle person. The use of Intel VTX and AMD V improve performance because the instructions are handled on the hardware directly rather than through software. Additionally, technologies such as these provide better security by isolating virtual machines. However, with that said, nested virtualization adds complexity because of the additional abstraction layer. Moreover, there is a significant performance overhead and requires more computing resources to be allocated to the guest. Of course, this is understandable. What is the acronym for a virtual CPU? vCPU. CPU. All right. What is the acronym for a virtual network adapter? VNet. What virtualization method allows for a hypervisor to be run within a virtual machine? Nested virtualization. Awesome. Moving to task 6. Okay. Guest additions. Put simply, guest additions are drivers and software that are used to enhance the functionality and performance of a virtual machine. They are installed on the guest machine and provide additional functionality like those in the table below. Feature description: enhanced performance. Guest additions allow the guest to use optimized drivers such as network adapter and disk drives, SATA, SCSI, NVMe, etc. Shared folder allows easy file exchange between the host and guest. This allows both environment to access specific folders that will be mounted within the guest. This is a very good feature, by the way. Shared clipboard. Much like shared folder, a shared clipboard allows the guest and host to access one another's clipboard, allowing files and text and images to be shared. Yeah, you can copy one file from the host and paste it in the guest. This functionality is very well known in the VMware side of the things. VMware workstation, by the way. Improved graphic drivers are installed to allow enhancements such as dynamic resolution. Hypervisor such as VMware allows for 3D acceleration, making better use of the host graphic card to improve graphics performance. USB devices. Guest additions also allow the guest to access the host USB devices. For example, you can mount a host webcam to the guest. Please note, in most cases, you are unable to access the device on the host whilst the guest has it attached. This is very true. Guest additions are generally installed after the VM's OS has been set up. Hypervisors such as VMware Workstation will attempt to install these during the VM's provision via the easy install if you use a supported operating system. However, guest additions can be installed at any time. To do so, you will need to mount the guest additions ISO in the guest DVD CD tray. Hypervisors store these ISO in different locations, but these are generally stored in the same place where the hypervisor program is installed. Additionally, there are multiple versions of the guest additions for different operating systems. So for VMware Workstation, the Windows are the host, and these are stored in C program files. x86 VMware Workstation on a default installation, as you can see here. So for Linux it will come like this, for Windows, for PG and NetWare, for Solaris, and then for WinPre Vista they have different additions. Okay, guest additions. Share folder, for example, screenshot below shows a shared folder defined in the VM options in the VMware Workstation with the option to map the shared folder as a network drive in the guest enable. As you can see here, this is coming from VMware VM. Now within the guest, we can see that the shared folder has been mounted and the guest can read and write to the respective folder on the host. Please note that it is possible to specify the shared folder as a read-only mode, where specifying it in the option. This is useful when you want the guest to see the files within the host folder but cannot write to it. It is a very good feature if you are doing a lot of research on the malware. You don't want this malware to write back to some of the files of your host operating system. Otherwise, this malware will spread across, right? So this is a very nice feature. Improved graphics. As the table mentions, Hypervisor can use guest additions to improve graphic performance in VMware 3D. Acceleration can be enabled. Okay. So in this case, 8 GB is recommended and it is assigned. They must be using some dedicated graphic card for this one in order to put aside the recommended RAM, right? Let's move forward. USB device. To attach a USB device to a VMware Workstation, left click on the USB device located at the bottom right of the display pane of the guest VM, and then you can connect it. It will disconnect from the host. We can now see that the USB device has been disconnected from the host and attached to the guest operating system. That is true. Guest perspective. Once guest additions are installed, services, drivers, and processes are added to the guest. The names of these will vary across Hypervisor. However, for VMware, you can see the processes named VMware tools on the guest side. Okay. Vulnerabilities. While guest additions add multiple useful features to a guest VM, they do potentially increase the risk of attack. For example, ransomware can potentially escape into the host in the case of shared folder. Yes, it's a very much possibility. Or a data leak can occur. Additionally, guest additions can serve as an opportunity for attacker to escalate their privileges, as these additions can run with elevated privileges due to their nature, and vulnerabilities within them can serve as a potential method for an attacker to obtain administrative privileges within the guest. Moreover, one of an attacker's goal is to perform a VM escape. This type of attack includes breaking the virtualization layer and escaping from the guest environment to the host. For example, in 2018, CVE 2018-2693 was disclosed within the guest addition of the VirtualBox. The CVE abused a vulnerability within the guest additions package to escape from the guest to the host. While these disclosures are rare, they are certainly not impossible. Likewise, who knows that zero-day vulnerability threat actors are sitting on and using for their benefits. Okay, what is the full CVE vulnerability that allowed attackers to exploit guest addition to escape the guest environment? Format is this one. So okay, so I will just copy from here and paste it here. All right, awesome. What name does the VMware guest addition process shows up on the guest? So VMware tool core services. So I will type VMware tools, core, services. All right, practical. So we will do being practical here. Press the green view button attached to this task. Your objective is to recreate the architecture diagram for both type 1 and type 2 hypervisor to reveal a flag. If you are stuck, you can revisit the content within task 2 to help you. Okay, what is the flag? Okay. Welcome to the hypervisor internals game. Drag and drop the correct label into the correct box on the image. Try hovering on the image to spot interactive areas. Labels can be dropped on these areas. Okay. Where is this is the app. Okay, so this is the app. This is also app. Come on. This is app. This is app. This is guest OS. And this is guest OS. Hardware is this one. Hypervisor is this one. You have done a great job so far. Let's gear up for the second task. Sure. Okay, so the app will run here. App will run here. Guest OS will be here. Hypervisor is this one. This is the host OS, and these are the applications, and this is the hardware here. Awesome, we have done so. Congratulations guys, we have done this. If you enjoyed this video, please give the thumbs up. If you haven't subscribed, please subscribe to the channel. Help us build a community around this channel. If you have any suggestions, please put it down below, and I will see you in the next video. Thank you very much.